SI. So we're going to talk about probability rules and distributions in Thursday's class, and so this first lecture is about probability rules. And there you go, rules of probability. When I'm talking about rules of probability, what I'm talking about is how we can combine different outcomes and talk about the probabilities of those different combinations of outcomes. So we'll use a binary random process where you either get a pink smiley face or a blue smiley face. We'll say we have a family that has 3 smiley faces in total. How many different ways can that happen? So we're talking about 3 different independent outcomes of the binary process, but then we're also talking about this other random process which is come up with 3 smiley faces. So there's sort of like this meta process. And this is how a lot of probability distributions get built. They say if you combine a bunch of previous processes together and treat that whole combination as a single process, what do its results look like? So and you can combine things in different ways. So let's look at that. So here we are. You have a family. The first smiley face it has is either pink or blue. And then the next stage, each of those successive smiley faces is either pink or blue, or pink or blue. And then the final stage, once again, we've got pink or blue. So we've got a tree with 3 choices leading to 8 different outcomes. And if we care about the order, if we want to know what the oldest smiley face is, then there are 8 different outcomes. Each of these outcomes is a uniquely different thing. So we can say that this single random process of producing either a pink or a blue, when you combine 3 of those in a row and care about the order of the results, then you get a random process with 8 different outcomes. So it's kind of analogous to the rolling 2 6-sided dice and adding them together. And that you're combining random processes together. However, if we don't care about the order, then you can see there's only 4 outcomes. Either you get 3 pink and no blue, you get 2 pink and 1 blue, you get 2 blue and 1 pink, or you get all blue. So caring about the order makes the outcomes more different. And if you don't care about the order, if you just have a mass of results, then the outcomes can be more comparable. So that first situation where we talk about order mattering is a situation that applies where the multiplication rule applies. So in this case, pink then pink, or pink then blue, or blue then pink, or blue then blue. Each of those is separate. And if we consider each of those to be an independent outcome, that is, whether you have what color your first smiley face is has no influence on what your second smiley face color is, then we can multiply the probability of a pink smiley face, of having a pink smiley face, times the probability of having a pink smiley face, and that gives us the probability of having 2 pink smiley faces, and so on. So we multiply the probabilities of successive results together to get our final probability. Now, when there's more than one way to achieve equivalent outcomes, so if pink, pink, blue is the same as blue, pink, pink, there's more than one way, then we add all the different ways to get to that equivalent outcome together, and that gives us the proportions of different outcomes. So for example, if we add 2 dice together, if the faces per color in a family of birth order doesn't matter, so there's only one way to get 2 pink faces, there's only one way to get 2 blue faces, but there are 2 different ways. And so if pink and blue are equally likely, then these two then there's 2 ways to get a blue and a pink, and only one way to get each of these, so this should happen twice as often as any of these. Or another way of saying is that half of the family should be a mix, and a quarter of the family should be all pink, and a quarter of the family should be all blue. If you take an A in biology, you recognize this as the result of a heterozygous cross with a Punnett square. And so the probability of the result, in this case, is the sum of the probabilities of the equivalent results. And that saying that more specifically works when these two aren't necessarily equally probable. So that is the introduction to the addition rule. And the multiplication rule. We will talk some specific examples on how to apply those in class, and that is the end of this video.